Hey, what's up guys? This video is for section 9.5, which is solving quadratic equations, and we are going to use the quadratic formula to do that. So this is part 2, and if you guys haven't seen part 1, go ahead and watch that because I do introduce the actual formula and a specific part of the formula, which is called the discriminant. But let's go ahead and look at that formula again here. So in that quadratic formula, we do have x equals negative b plus or minus the square root b squared minus 4 times a times c, everything divided by 2 times a. When can we use the formula? If you guys have a quadratic equation and the quadratic equation is in standard form and everything is equal to 0, then you guys can use the formula to find the x-intercepts or to solve the quadratic equation. Now, remember that you can also factor quadratic trinomials when you guys have those trinomials in a quadratic equation, or perfect square binomials, perfect square trinomials, difference of two squares. But the quadratic formula, you don't have to factor. It just works when you substitute the values of a, b, and c into the formula, and then you guys simplify. When you guys have the standard form, sometimes you might be missing the b term in the middle. You might be missing the c term, the constant, and that's okay. You're just going to put, if you're missing the b term, you are going to substitute b equals 0. If you are missing the constants, you are going to substitute c equals 0. But you can never be missing the a. A has to be 1 or something else, because if a is not present, that means you guys don't have an x squared, and therefore it's not a quadratic equation if you don't have an x squared. Also keep in mind, I already mentioned this, but to use this formula, you guys need to use the quadratic equation, and it has to equal to 0. So make sure that you guys know your a value, which is the one with the x squared, your b value, the one with the x, and your c value, your constant, is the one with no variable. On my previous video, like I mentioned at the beginning of this video, I talked about the discriminant inside of the radical, which is the square root. That's the name of the symbol, radical. And the discriminant helps us know how many real solutions we are going to have. So there's 3 options. You guys can have no real solutions, 1 real solution, or 2 real solutions. So that I'm going to talk about the discriminant today as well, and I'm going to look for the type of real solutions I'm going to have and how many, and then we are going to actually find the solutions. Now, another word that you might see on tests or in textbooks or your teacher might use are the x-intercepts. You can use the quadratic formula to find the x-intercepts. You guys can use the quadratic formula to find the solutions. You guys can use the quadratic formula to find the roots of the quadratic equation. Or you can also say you can use the quadratic formula to find the zeros of the quadratic equation. So all of those vocabulary words, solutions, roots, x-intercepts, zeros, they are just the same thing, the same concept. You want to know what is the x value. So let's go ahead and look at some examples here. So I have this example, and it says find the x-intercepts of the following equations. So once again, the x-intercepts are just the solutions, your answer for x in that quadratic equation. And when we say x-intercepts, that means that we're looking where is the parabola going to cross the x-axis. And in my previous video with discriminant, I also explained what does it mean when you guys have a positive discriminant, negative discriminant, or a 0 discriminant. So make sure you guys check out that video as well. But let's go ahead and look at these 2 equations. And the first one, we have a 3x squared plus x minus 4 equal to 0. First of all, I need to have the equation equal to 0, and we are good with this one. It equals to 0. So all I have to do is find the a, the b, and the c. Something else that also helps you guys a lot is if the standard form, this equation, is in order from highest exponent to the lowest exponent, and the last one is your constant. So when I look at the exponents, I do have a square, which is the highest one, and then a 1, and then your constant. So this is standard form. It is in order from highest exponent to the lowest, and then the constant. I'm going to look for my a value. A is going to equal the coefficient in front of the x squared, so there's a 3 in front of the x squared. B is the coefficient in front of the x, so we have an invisible 1, so b equals 1. Positive, there's a plus 1x. and c is your constant, which is a -4, the one with no variable. Now I'm going to use the formula. Let me write down the formula this time so you guys know where to substitute the numbers, but throughout the video I'm not going to write down the formula per se. I'm just going to use parentheses instead, but let me write that down, that formula for you guys. So you guys see the formula there. -b plus or minus the square root of b squared minus 4 times a times c divided by 2a. So all of that is going to be your x value. Now what I do is when I'm ready to substitute those variables, the b, the a, and the c, I will make them parentheses, and then I'm going to substitute the variables in the corresponding spot. So let me change those variables into parentheses. So now you guys see the formula with parentheses, not the variables, and I'm going to substitute the corresponding value of the variable into the specific spots. So the first one is -b right here, so b is 1. I'm going to substitute a 1, and then we have plus or minus b squared, so there's the 1 again, minus 4 times a, so 3 is a, times c, -4, over everything divided by 2 times a, which is 3. You guys are going to simplify, so I'm going to go to the next step. I have x equals, I do multiply the negative times the positive 1, and that's going to be a -1 plus or minus the square root, and I'm going to do what's inside of the radical, and that's called the discriminant, just the inside, not with the square root, it's just a number inside. So I'm going to find out this discriminant, and it is 49 inside of the radical. Now let's talk about that discriminant for a second. The discriminant is 49, the number inside. Once again, inside of the radical, it is positive. So when the discriminant is positive, that means we have two real solutions. We're going to have two different answers. But the bottom, let's go ahead and finish the bottom of the fraction. Everything is divided by 6. 2 times 3 is 6. Now, 49, it is a perfect square number. We can find the square root of 49. So you guys go to the next step and you simplify that 49, the square root of 49. So I'm going to put equals here, -1 plus or minus, and the square root of 49. Let me just circle that here with the bubble. The square root of 49 is 7. So let me put that 7 there, over 6. Now, very common mistake. Some people like to use the square root again right here. Let me just show you guys what they do. They put the square root of 7. Wrong. You guys do not use the square root again, because when you take the square root of 49, the answer is 7. So you take the square root, but you don't give it back. So it's just 7. And it is a perfect square number, 49, so that's why the square root of 49 is 7. Now you guys, since we don't have a radical anymore here, notice the 7, like I mentioned, you don't need the radical. And we do have a -1 here, plus or a -7 over 6. We're going to have to split the plus and the minus into two different equations, or not equations, into two different fractions, and then you simplify. So my next step will be x equals -1 minus 7 over 6. Notice I don't use the plus in the middle. I use the minus, comma, -1 plus 7 over 6. So you guys simplify the fractions, and then you guys will get your answers. Now notice that I split the plus and the minus. One fraction has a minus, the other one has a plus, everything else is the same, but you guys do have to simplify the fraction here. So we have a -1 minus 7 on the top. That's -8 over 6. And we can reduce that fraction. So x equals, you can divide by 2. You guys can reduce by 2 here. So we get -4 over 3. Now the other one, let me put a comma here. You guys have a -1 plus 7. That's 6. And on the bottom we have a 6. And 6 divided by 6 is 1. So sometimes you can get fractions, sometimes you can get a whole number, sometimes you guys get a mixed number. I don't like to use mixed numbers. You can actually turn this into a mixed number, -1 and 1/3, but I'm okay with improper fractions in my class. So just ask your teacher what they want for you guys to have in your answer. But like I said, mine, improper fraction is fine. So those are your two real solutions. One of them is a fraction, -4 over 3, and the other one is 1. Two real solutions, and we know that since the beginning of the quadratic equation or the quadratic formula, because the discriminant is positive. And since those are your x-intercepts, what it means, guys, your parabola is going to cross at those points on the x-axis. And let me just show you guys this really fast with the graph. It's not going to be perfect. I'm not going to make an accurate parabola, but I do have 1 on the x-axis is right here, and negative 1 1/3, negative 4 over 3 is negative 1 1/3, is around right here with the negative. So the parabola is going to go through those points. The U-shape is going up because the A value is positive. So you guys will have a U-shape. I don't even know what the vertex is, but this is just to give you guys a visual, an idea. We found where the parabola is going to cross the x-axis at these two values. Now this one, we have x squared plus 11 equals to negative 8. Well, it's not equal to 0. So first of all, let's get rid of that minus 8. Let's send it to the other side. And we're going to do the opposite. So I'm going to add 8x here. And I'm going to add 8x on the other side. So notice that on this side, the x squared, the 8x, and the 11, they're not like terms. But I'm going to write it in order from highest exponent to the lowest one. So this is standard form. So I'm going to have your x squared plus 8x plus 11 equal to, cancels, 0. You guys are going to find your a, b, and c. So a is your coefficient with the x squared, so we do have an invisible 1. B is the one with the x, positive 8, and c is 11. I'm going to write down the formula, the quadratic formula, but I am not going to use the variables. I'm just going to set it up with parentheses so I can substitute. And you guys see that formula there with parentheses. It's ready to substitute the numbers. So I have a negative b, so 8 is b, plus or minus the square root of b squared, so that's 8 squared minus 4 times a, 1, times c, 11, over everything over 2 times a, which is 1 again. You guys are going to simplify, so x equals, you guys multiply the negative times the 8, that will be negative 8 plus or minus the square root. I'm going to find the discriminant, the number inside of the radical, and it's 20 inside of the radical. Everything over 2 times 1 is 2. Now look at the number inside of the radical, 20. That discriminant is positive, so that means we're going to have 2 real solutions. But 20 is not a perfect square number. So here's what we have to do, guys. If you have a radical square root with a number that is not a perfect square number, you guys are going to have to simplify, which means you're going to have to make that radical smaller. And there's a couple ways, actually a few ways you guys can simplify, but I'm going to show you guys my method, the one I use to simplify those radicals. So I'm going to have to move this here on the side, and I'm going to write down the square root of 20 here. So I'm going to simplify this radical. What I do is I use the prime factorization, or some people like it the prime tree, or the tree prime. You guys are going to find two numbers that multiply to 20, and you are going to try to make those numbers, all of those numbers, to be prime numbers at the end. So I know that 2 times 10 is 20. You guys can break down the 10, and the 10 is 2 times 5, and the 2 and the 5, those are prime numbers. And I'm going to start making pairs of numbers. So I do have this and this one here, the 2 and the 2, they make a pair of 2s. Pair means two number of 2s, or 2 quantities, or whatever you have. So we have a pair of 2s. So that pair of 2s is going to go outside of the radical. Since we have one pair, we're going to put 1, 2 outside. If you guys have 2 pairs of 2s, you put 2 2s outside. But right now it's 1. And the 5, the one that doesn't have a pair, is going to stay inside of the radical. So I'm going to have x equals negative 8 plus or minus 2 outside of the radical, and the 5 inside of the radical. Everything divided by 2. We simplified the radical. This square root of 20 became 2 square root of 2. So we simplified. But now there's something else you have to also check. The numbers outside of the radical, those 3 numbers, not the one inside, just the numbers outside, you have to check if you can simplify just like a regular fraction. So this is what I mean. 8 and 2, you guys can divide. 8 divided by 2. 2 and 2, you guys can divide. 2 divided by 2. So every time you guys have the quadratic formula, I like to draw a triangle so I can tell you guys, hey, look at the triangle outside of the radical, the three numbers. And if you can simplify all three numbers by a specific common factor, do it. If you cannot simplify all three numbers, then you guys are not going to simplify. So here I can actually simplify by 2. I can divide every number by 2. So negative 8 divided by 2, that's negative 4. Plus or minus negative 2 divided by 2 is 1. The square root of 5, I keep the same number inside of the radical. And on the bottom, 2 divided by 2 is 1. You guys already know in a fraction, we don't need a 1 under on the bottom. So I can make this equal to negative 4 plus or minus. I don't even need the 1 outside of the radical here. So I'm going to have the square root of 5. Now you guys have to understand what you're looking at. Here we have two different answers. It's okay to actually write your answer like this, negative 4 plus or minus the square root of 5, because that is a radical form. Radical, remember, that's the square root. And you guys can leave it as a radical form, but make sure you guys have a plus and a minus in the middle. Or you guys can separate the two real solutions that we talked about when we look at the discriminant. So if you split the plus and the minus, one answer will be negative 4 minus the square root of 5, and the other answer will be negative 4 plus the square root of 5. So again, you can ask your teacher what they want for the answer, but you guys can have this answer, negative 4 plus or minus square root of 5, or this answer, negative 4 minus the square root of 5, comma, negative 4 plus the square root of 5. So I'm just going to put a box around the two, so either one works in my class. Now something else that you also have to understand is, even though we have radical form here, you can actually turn those into decimal forms. If you put this here in your calculator, it's going to give you guys a decimal. And if you actually put this again with the plus in the middle, you're going to get a different decimal. But every time we use the quadratic formula, it's very common to use radical form, not decimal. Right, so let's look at another one here. 3x squared plus 8x equals 2. So let me just zoom in here so we can make it a little bit bigger. You guys have to have everything equal to 0. So that 2, I'm going to take it to the other side. I'm going to do the opposite. I'm going to subtract 2. So I have 3x squared plus 8x minus 2 equal to 0. So that cancels. I'm going to look for my a value. The one with the x squared, that's a 3. B is 1 with the x, that's an 8. And C is negative 2. I'm going to write down my formula, and I'm going to use parentheses again so I can use it to substitute the values. And I am ready to substitute. So here we have a negative b, so that's an 8, plus or minus the square root of b squared, 8 squared minus 4 times a, which is 3, times c, which is negative 2, everything divided by 2 times a, which is 3. I'm going to simplify the fraction, or the formula. So x equals, you guys multiply the negative and the 8, that'll be negative 8 plus or minus the square root, 88, everything divided by 6. 2 divided by 2 times 3 is 6. Now the discriminant is positive 88, so that means I have two real solutions, and 88 is not a perfect square number, but let's go ahead and try to simplify the radical. So once again, I'm going to take my radical here, the square root of 88, and I'm going to break it down using prime factorization, and then I'm going to start making pairs. So two numbers that multiply to 88, I know that's 4 times 22. 4 is 2 times 2, so notice we have a pair right now. But 22, that's 2 times 11. And all of those numbers here are prime numbers, the 2 and 11. So I can make pairs of these 2's. So 2, 2, that's a pair. This one here doesn't have a pair. These 2, I don't have another 2 to make a pair. And 11, I don't have another 11 to make a pair. So what that means, guys, since we have one pair of 2's, you can put 1, 2 outside of the radical. And these 2 are going to go inside of the radical. But you're going to have to multiply the numbers inside of the radical. So eventually, 2 times 11, you're going to put a 22 inside of the radical. So I'm going to have x equals negative 8 plus or minus, there's a 2 outside of the radical, and I'm going to multiply 2 times 11 is 22, and on the bottom I have the 6. Now let me go back again. There's a pair of 2's, one pair, so that's a 2 outside, 1 2 outside. These two don't have a pair, but I do multiply those two. 2 times 11, 22. 2 times 11, 22. I'm going to check the triangle outside of the radical. So I have a 8, a 2, and a 6, and I can divide by 2. So x equals negative 8 divided by 2, that will be negative 4, plus or minus 2 divided by 2 is 1. The square root of 22, do not divide the number inside of the radical. You don't simplify the inside, just the ones outside. So the 22 says the same, inside of the radical. And on the bottom, 6 divided by 2 is 3. So guess what, guys? On the bottom, we do need that 3 because it's not a 1. So you need in your answer the 3. And this 1, we don't actually need it. You guys can erase it if you want to, but it's okay if you guys have it as well. But the answer is actually this right here. Now, do you guys have to split the plus and the minus? No, you don't have to. But remember, keep in mind, we do have 2 real solutions, 2 real answers, because one is with the plus, negative 4 plus square root of 22, and the other one is negative 4 minus square root of 22. So let me just rewrite that without the 1 here. So my answer will be, without the 1, x equals negative 4 plus or minus the square root of 22 over 3. Now this one here, x squared minus 4 equals 0. Notice we are missing one of the terms. We do have an x squared, that's your a value. We don't have an x, that's going to be your b value, so we are missing the bx term. But we do have a constant, the minus 4 is the one with no variable, so we have c. So everything's equal to 0, so that's already set up to find your variables. So my a value is going to be your invisible 1 here, so there's a 1. B is going to equal 0 because that's what we're missing, the bx term, and c is going to equal to negative 4. Now guys, even if you're missing the bx term or the constant, you guys can use a quadratic formula. Just make sure you guys use zeros for those variables that you're missing. A will never be 0 in a quadratic equation because you must have that x squared term, so it's going to be 1 or something else. So you guys can substitute the values into the formula. And here's the formula. So we have negative b, which is 0, plus or minus the square root of b squared, which is 0, minus 4 times a times c, everything divided by 2 times a. Now, let me give you guys also something else you can use to solve this quadratic equation. If you guys want to use the square root property, you actually can with this equation because you are missing the bx term. So that means that you can add 4 to both sides, and then you take the square root of x squared to cancel the square. And I do have a video about the square root property. Make sure you guys can check that out if you want to, so you understand what the square root property. But this is what's nice about the quadratic formula. You guys can use a quadratic formula no matter what is the quadratic equation. You guys don't have to factor. You can use the quadratic formula. You guys don't have to use the square root property. You can use the quadratic formula. But sometimes it's a lot easier to factor versus the quadratic formula. Sometimes it's a lot easier to use the square root properties instead of the quadratic formula. So it just depends. Some people like the quadratic formula, and that's what they use all the time. But here, I'm just going to simplify the formula. So negative times 0, that's just 0. So we have 0 plus or minus the square root 16 over 2. Now you guys look at the square root. The square root of 16, 16 is a perfect square number. And 16, the number 16, the discriminant is positive. So that means I'm going to have 2 real solutions. So I'm going to keep the 0. I'm going to keep going. 0 plus or minus the square root of 16 is 4. So I'm going to put a 4 right there. Everything divided by 2. Now the 4 doesn't have a radical, so I need to split the plus and the minus. You separate the plus and the minus, and you guys make 2 different fractions. So one is 0 minus 4 over 2, and the other one is 0 plus 4 over 2. Now you guys are going to simplify the fractions. You guys need that 0? Not really, guys, because you're not adding or subtracting a number. 0 is nothing, it's empty, so you guys don't need it, but this is just to give you guys a visual what happens to the 0. So if you guys simplify the top, 0 minus 4, that's negative 4, divided by 2, that'll be negative 2. And over here, 0 plus 4 is positive 4, divided by 2 is positive 2. So we do have 2 real solutions. And we don't have a radical or a fraction anymore. So that can happen as well. All right, so let's look at these 2 examples, just to have more examples. And I'm trying to show you guys different scenarios that you can have when you use a quadratic formula, because it can change every time you guys use the formula. So I'm trying to show you guys what you have to look for and how to simplify the formula. So let's look at this one here. Okay, we have 4x squared equals 16x minus 16. So first, I don't have equal to 0. I'm going to take everything to one side. When you guys have an x squared here, I like to keep that number positive if it's already positive. So what I'm going to do, I'm going to take this to the other side and this one to the other side instead of taking this one to the other side. You guys can do that, but you're going to have to subtract 4x squared. I don't like to have that negative a value, so I'm just going to do this opposite and take those to the other side. So plus 16x, I'm going to subtract 16x here, and the plus 16, I'm going to add 16 over here. So I'm going to subtract 16x, and I'm going to add 16 over here. Now these terms are not like terms right here, so I'm not going to combine like terms, but I am going to put it in order. So I have the 4x squared minus 16x plus 16, so that is standard form, it's in order, equal to, cancels, 0. All right, so now let's look for our a value. Everything is equal to 0, so we're ready to solve. A equals 4, the one with the x squared. B equals negative 16, the one with the b with the x. And C is positive 16. Let's go ahead and use the formula. And let's go ahead and substitute. So negative b, that's a negative 16 here, plus or minus the square root of b squared, negative 16, minus 4 times a, which is 4, times c, 16, everything divided by 2 times a, which is 4. Let's go ahead and simplify the formula. So x equals, we have a negative times a negative 16, that's going to be a positive 16, plus or minus the square root. You guys are going to use your calculator to find what this is, the discriminant. And it equals to 0 right here. And on the bottom, 2 times 4 is 8. Now let's talk about the discriminant. Discriminant is 0. When the discriminant is equals to 0, that means you have one real solution. So we're going to have one answer. And the square root of 0 is 0. It is a perfect square number. So I'm going to keep going. I have 16 plus or minus 0. Right here, guys, the square root of 0 is 0. I don't have a radical anymore. Everything divided by 8. Since I don't have a radical anymore, I'm going to separate the plus and the minus, and I'm going to simplify my fractions. So x equals 16 minus 0 over 8, everything divided by 8, and 16 plus 0 over 8. Now, do you guys need that 0, the minus 0 plus 0? No, because you're adding, subtracting. 0 is you're not adding anything or subtracting. But once again, this is just to show you guys what happens to the 0. So when you simplify, 16 minus 0 is 16 divided by 8. So that's going to be 2. And over here, if you guys do this, 16 plus 0 is 16 divided by 8 is 2. Now, I know what you're thinking. I said we have one real solution because the discriminant is equal to 0. But guess what, guys? We say this is a double root, or it's a multiple of 2. You guys have a number that is showing multiple times. It's repeating 2 times. So when a solution is repeating, you guys don't have to write it down twice. You guys just put x equals 2. So that's where it's one real solution. It is repeating 2 times. We have the same answer 2 times. We have multiple times that is repeating, but it's only one time. Now, what does it mean? It means that the parabola is going to cross only one time. Actually, it's not going to cross, it's going to touch one time on the x-axis. And just to give you guys an idea, I'm going to draw the parabola for you guys here. Positive 2 on the x-axis, x equals 2 is 1, 2 right here. That's x equals 2. And your parabola, since a is positive, is going to go up. Now, this is not an accurate parabola, just to give you guys a visual, but that's what it is. The vertex of the parabola is at x equals 2 because it's only one real solution. Now, the parabola can also go down, and it can be on the x-axis at one point, but we know that it touches at x equals 2. And more practice here, guys. Let's solve for this one. 2x squared minus 5x equals negative 7. So I am going to do the opposite of the 7. I'm going to add 7 to both sides. So we have 2x squared minus 5x plus 7 equal to 0. I am ready to find my a value, which is 2. B is negative 5. And C is positive 7. I'm going to use the formula. And I am going to substitute. So negative b, negative 5, plus or minus the square root of b, negative 5 squared, minus 4 times a, which is 2, times c, which is 7. Everything divided by 2 times a, which is 2. I'm going to simplify the fraction, or the formula. So we have a negative times a negative 5. That's a positive 5, plus or minus the square root, negative 31. Everything divided by 2 times 2 is 4. Now, guys, right here in that radical, negative 31, that discriminant tells you guys that we have no real solution because it's negative. The negative inside of the radical, you guys don't have a real solution. So you guys can't really simplify the square root of negative 31. Now, why? Because we have to use imaginary numbers in order to do that. But since we are not doing imaginary numbers in Algebra 1, you're actually going to do that in your upper math classes, which is Algebra 2 and beyond. But what we are going to do here, in this case, since we have a negative inside of the radical, we say our answer is no real solutions. And I'm going to put an arrow here so you guys know this negative is no real solutions. Now, what it means, the parabola is not going to cross the x-axis. It's not going to touch the x-axis. It's going to be on top of the x-axis going up, or it's going to be on the bottom of the x-axis going down. So it's never going to touch that x-axis. But that's why we need imaginary numbers, because in a number system, that's what we have. We have real numbers and imaginary numbers. But here, like I said, guys, we're just going to write down no real solutions because we have a negative inside of the radical. Doesn't matter what number you guys have. You can have a negative 1, negative 10, negative 1/2, negative 100. But since it's negative inside of the radical, we say there's no real solutions. All right, guys, so this is my conclusion of this video. So if you guys like my videos, you guys can hit that like button. You can subscribe to my channel and make sure you guys practice your math, and I'll see you guys later.